আসসালামু আলাইকুম সবাইকে। আজকে হচ্ছে আমাদের মাস্টার্স থিসিস ডিফেন্স। সো আমি নার্গিস আর আমাদের ক্লাসমেট মুফাদার ইয়াসমিন হচ্ছে প্রেজেন্টেশন দিব আমাদের মাস্টার্স থিসিসে। সো দেখা যাক কি হয়। Good morning everybody. Let me share with you a short story first. In 2020, I went to Characterization for college research with my research team, and I found that basically agricultural crops have already been converted into different farms. So that is very good. From that point of view, I tried to work on this. I am Samuma, master's student, Soil and Environmental Sciences Department, University of Oregon. I am going to present my master's thesis entitled Production and Characterization of Slow Pyrolysis, Acid Modified Biochars and their effect on soil saline. And it was supervised by Dr. Pyrolysis, Assistant Professor of the Department of Soil and Environmental Sciences, University of Oregon. So let me share with you the background of the thesis. You know that more than 100 countries in the world have already been affected by soil saline. However, in Bangladesh, 0.83 million hectares of farmland are saline and offshore lands. If you can see figure number 1, these are the saline zone of our whole Bangladesh. So there is a huge lack of information in the collection of biochars, most importantly from pineapple crop. Now I know you have a question in your mind why I consider pineapple crop to be a biochar. Now, pineapple crop is a waste and it is a potential risk for the ecosystem and the environment. Finally, the study investigated the characterization of slow pyrolysis as a modified biochar and the effects of soil salinity. Basically, soil salinity has an adverse effect on soil productivity. The use of biochar can be a great solution for this problem. After conducting the literature review during my thesis, I found that some authors try to produce biochar from different kinds of agricultural waste. However, I found very few articles where they try to prepare biochar from pineapple crop. And that's why I considered this one. In figure 2, you can see biochar can be a great solution to replace sand soil with different kinds of properties, like it can enhance the properties of soil with surface area and porosity of the soil. Then with different kind of functional group, it can also improve the exchange of ions, organic carbon and nitrogen. So what are the objectives of my thesis? I have 3 objectives. First one is to investigate how temperature affects the physicochemical properties of the biochar. Number 2, to develop biochar with diverse properties and understanding their functionality. Number 3, to develop different types of acid modified biochars and ranking them according to the effectiveness of the saline soil regulation. So in figure 3, you can see I tried to illustrate how I conduct the whole project. Like I collected biomass like pineapple crown and then biochar acid modification and then on feather tube. On the other hand, I collected soil sample and then prepared the sample for laboratory analysis and then we conducted the incubation study for 10, 20 and 30 days of total experiment. I had 3 hypotheses for the study. Biochar physicochemical properties change significantly with higher temperature. The availability of the functional groups of biochar, especially on the surface of the biochar, can be affected by the production temperature of the biochar and acid modification. 3. Acid modified biochar will significantly affect the soil physicochemical properties like pH, yeast monopolypsy, and organic carbon. So you can see now I am going to describe the materials in the box. You can see in figure 4, I tried to illustrate the map. I prepared the map using ArcGIS, so it's whole Bangladesh, and it's like light green and deep green, total Shakira district, and most importantly, our study area in Shamapur, like from this point, the study area. And in figure 4, you can see the visualization of the soil sampling, soil preparation, and others. So let's talk about the biochar production and modification. As I told you earlier, I collected the waste pineapple crop from a local storehouse in Oregon City. So you can see I try to show it with different arrows like biomass collection, the biomass washing, the air drying of biomass really important for the biomass. And most important part is biomass pyrolysis. I followed the method that was prescribed by Phil et al. In 2016. And then I conducted a modification of the biochar with different acids according to the Biochars et al. In 2018 with slight modification. So then different the process, and then we found the modified biochar that was applied for the experiment. Laboratory analysis, we conducted several laboratory analysis. Let me explain, like soil temperature class, that is particle analysis were done with the hydrometer methods, while the moisture content was done with barometric method. The pH and EC of the soil cell biochar were analyzed using pH meter, and for the EC we used the EC probe. Determination of the functional groups of biochar used FTIR, that is Fourier transform infrared spectroscopy. And for determination of the water molecule capacity, we followed the method that was described by ASTM, that is American Society of Testing and Meteorology. The determination of the organic part, we followed the web oxidation method. Let's move on. Here you can see in figure A, I tried to illustrate the incubation study. And for the incubation study, we took 20 gram air dried sand soil and 5% each biochar in each fellow tube. For the data analysis, we conducted several kinds of analysis. You can see here the short list like experimental analysis, as we had several time intervals. We considered the mixed method, mixed model at home. The two EHS tests for the main separation, and then correlation. Most importantly, we used the Pearson correlation to find out the correlation of the parameters. And the FDA data analysis using nitric software and SIGMA plot. So let's talk about the results and discussion. Firstly, I would like to say, in figure 9, you can see, with increasing the temperature, the early capacity of biochar has been decreased. On the other hand, the weight loss has been increased. That is the very first finding of my thesis. The early capacity and weight loss of biochars. So I tried to show the water holding capacity terms of the biochars, pH, and to the conductivity. Like you can see, there are three figures. All figures show the same pattern. Right? With increasing the temperature, the pH, EC, and water holding capacity has been increased. So there might be some regions like for water holding capacity, we know that biochar porosity tends to be increased with temperature. So when we increase the temperature, the water holding capacity of biochar has been increased. On the other hand, for the pH, when we increase the temperature of biochar reaction, we found that the pH has been increased. We know that with increasing the temperature of the biochar reaction, the acidic functional groups, the number of acidic functional groups will be decreased. That's why the pH has been increased. And mainly the electrical conductivity of the biochar that was increased with temperature, what would be the result behind this? Well, the ash content. Because when we increase the temperature of the pyrolysis, the ash content will be increased. That's why the electrical conductivity has been increased. The most important part of my thesis, the most important findings of my thesis, is that here a spectrum of biochar samples produced at 300, 350, and 400 Celsius. You can see in figure 11, I tried to show some screenshots that were taken from the liquid software. Like we used Gaussian, Laurentian function to figure out the exact speed for each functional groups. Most importantly, the acidic functional groups. And we try to combine all of the graphs in one graph, like you can see in figure 12, that your spectral biochar samples produced at different temperature. So let me show you, like for the biochars produced at 300 degrees Celsius, we found nitric acid modified biochars pyrolysis at 300 degrees Celsius. We found maximum number of acidic functional groups. That's why I really would like to consider this one that would be suitable for the standards of regulation, as we found that pH and EC lowering can also be done with the nitric acid modification. So let's move on. For the biochars pyrolyzed at 350 and 400 degrees Celsius, we found a very small amount of acidic functional groups. That's our concern. So we are considering here the biochars pyrolyzed at 300 degrees Celsius will be the most suitable one. Most importantly, nitric acid moderated biochars pyrolyzed at 300 degrees Celsius. Let's come to the main effect of biochar on soil pH. We conducted the integration study for 10, 20, and 30 days, as I told you earlier. So we found that the soil related with nitric acid moderated biochar pyrolyzed at 300 degrees Celsius shows the lowest pH throughout this step. And for the electrical conductivity, we also found that according to the figure number 14, the nitric acid modified biochar related soil shows the lowest, which is our very important concern for the step. For the overall capacity, we found several findings like biochar, the soil related with sulfuric acid modified biochar at 350 degrees Celsius showed the highest level of overall capacity. However, that is more than 100%. And our concern is nitric acid modified biochar pyrolyzed at 300 degrees Celsius. So how it works for the soil? It shows more than 80% for all of the minerals. So we can consider this one for the reclamation of the saline soil. Finally, correlation among the PHC and all other parameters that we consider for the study, we found that after conducting the careful correlation, we found that at 30 days of incubation, all show positive correlation throughout the study. Most importantly, for the 30 days of incubation, and that was significant at 0.05, 0.01 level. So let's conclude this, like acid modification of biochar, amendments, and improve the physicochemical properties of the saline soil, and most important findings of my study is biochar pyrolyzed at 300 degrees Celsius with nitric acid modification and the most suitable one. The mechanisms responsible for different properties change should be further investigated. However, future research will explore the effect of acid modified biochar with slow pyrolysis on crop growth in saline soil. So these are the references I added throughout this presentation. Let's acknowledge those we don't, I couldn't able to conduct this slide. I'm very much thankful to Almighty Allah. I'm also grateful to our supervisor, Dr. Thesis, for our unconditional help and academic supervision. I was grateful to Dr. Muhammad Begum and all the teachers, administrators, and office staff throughout this study as they helped. And I was grateful to Dr. Asma Hakim and Dr. Shamim Yasser because they helped me a lot throughout the study, like to conduct the FGR analysis and to prepare the biochar and modification of the biochar with scientific way. I was grateful to the SRBA Odisha and Department of Chemistry of University of University of Chicago, as they provided me with the laboratory facilities for parts of my research work. So, thank you so much. That's all for today, and I hope you have some questions, and I'm ready to answer. Thank you.